Yes, try to set up the account as soon as possible. You need it. Um, you can start it after right after class, and they also work at weekends. They work 20 hours a day and 7 days a week. So you, you know it should not be a problem. Okay, just be patient when you call them. Okay, you don't have to be waiting for them and doing nothing. You can do everything else if you want. Just leave it on and calling. Just wait. Just leave your phone on the dialing uh, to them, and then
So,
when they pick up, then you can just talk with them and ask them to help you set up account. It will be real quick. So that's the account. I also send the email to uh, yeah, to the class, to the students, and also the post the announcements in Blackboard. I give the number for the Syncage Sport for you to call, and also the link for Mr. Huck's help hours or office hours that you can join to seek help from him. Okay. I also downloaded. I also download. Uh, okay, one second. I also downloaded the video on Wednesday of Mr. Huck's training session. So I'm going to give you the link for his recorded the video of training on Wednesday again as I did before, and then you can watch that to get some help also. So that's another thing. But the bottom line is we need to get the account set up as soon as possible, and it would be good if we can get ready next time when we have class. That's my hope. Um, so please do it. Yes, as I said, if you help others to create an account, then yes, that will be part of the class activities in the toward the final grade. If you look at the syllabus, yes. So please help others and uh, to set up account and to make website working. Mr. Blackwell, Jamaica. But I need to know, yeah. But some others needs to tell me who helped them to set up. Okay. Uh, any other questions? Anything? Mm.
yeah,
So that's
I
the
have a
major thing
question.
I want to emphasize again and again because
I have a question.
without the account you cannot do anything. All right. So please try to set up the account early next week. I don't think you can hear us. No, I can't. I cannot hear us at this point. I already reported a issue in Blackboard Collaborate to them for this voice issue. I cannot hear you, and I hope they can resolve it, fix it soon. Okay, because I tried different ways, and I called the technical support, and they didn't. Uh, Give me the right direction. They say they should work, but it doesn't as they had tried to do it. When I going to reopen the quiz, again, you need to set up the account first. If you don't have the account, the website to do it, what's the point of reopening the quiz? So I need everyone to get the account created and working in WebAssign, and then I will consider to reopen it. I, they, okay, yeah, you have account, but some other people don't have it now, so I cannot just reopen it for part of the class. I need to reopen it for the whole class if I want to do that. So um, So yeah, please get the account fixed. I will not reopen it before the people can get the account fixed. Okay, that doesn't make sense at all for me. Okay, any other questions you can type in here before we actually start the lectures for today. Um, if you don't have any more questions, why don't we just start the materials today? Okay. You can, if you have any more questions, you can also ask me after the class. I'll be here for a little more time. So let me just load the files, add the files from my laptop. I don't think we finished the 1.2, so we're going to continue to do 1.1 and 1.2 and try to finish today. All right. Okay, let's see. I think we were doing the applications. Okay. Okay. I don't know where we were last time. Does anybody still remember where we were last time? Did we do this page? Did we do this example? Yes. Okay, good. I'm glad you still remember. How about this one? No. Okay. So let's just continue from here. Let's do some more application problems in linear functions. Can somebody add me to the group? Okay. Okay. So, so the cost of a commercial product is 18 cents per atom, while its sale price is 75 cents. Okay, so you get a good profit from it, isn't it? So if a businessman made a profit of $2,000, $337 from it, how many atoms did he sell? Okay, so we know the cost of the atom, we know the price of the atom, so we can easily calculate the profit for each item, and then the businessman uh, got the total profit of $2,337. So he has sold a lot of atoms, right? So again, how do you start this problem? You always start from assigning a variable for the question asked in the problem. So we need to know how many atoms did he sell. So why don't we just let X be the number of atoms he sold for the commercial product? Okay. And then you can use the conditions given in the problem to set up an equation and solve the problem. So we can calculate the total profit by multiplying the numbers of sale and the profit for each item. And we know the profit for each item is the price or revenue minus the cost. So that's 0.75 minus 0.18, okay, in dollars. And then multiply this by the number of sales. That gives you the total profit. Okay, then you got 2,337 equals 0.57x. 0.75 minus 0.18 is 0.57. And then you solve this problem by dividing by point on both sides. So you got 2,337 over 0.57, you get 4,100 atoms. So he sold 4,100 atoms to make this profit. Any questions about this problem? Okay, this should be easy. Okay, no question. Let's just do the next. Okay, this question is the one that related to investment. Okay, so if somebody major in business, you probably want to know how to, make a good profit, make good money from your investments, and if you have several commercial products, some financial product, financial investments, how much you should invest in each product. So in this problem, it says a accountant invests part of a $6,000 bonus in a 5% simple interest account and invests the remainder of the money at 8% simple interest. So he has two accounts or two plans or two commercial products or financial products that he can invest. And then in each plan, he can get some interest. Together, the investment they earn $370, per year. So we need to find the amount invested at each rate. Okay, we know the total amount of money he has is $6,000. That's called principal. And he put this $6,000 into two accounts, one with the 5% interest and the other with the 8.5 interest. And then at the end, he got the $370 in total for the interest. So we need to calculate the interest from each plan, each program he invested. And the formula for a simple interest is the interest earned is equal to the principal times the interest rate. So it's very simple. So for example, if you put $1,000 in the account of 5% interest rate, and you just multiply 1,000 times 5%, and then you get $50 for the interest for the whole year. All right. So he has two accounts, so he got a interest from both accounts, but we don't know how much was the principal. How much did he put in each account initially, and that's what we need to find. So let's just again start from assigning the variable to the question asked in the problem. We need to find the amount invested at each rate. So you can choose any rate program to start. For example, if you choose the 5% rate plan or program, then you will let X be the amount of money invested in this 5% simple interest account. Okay. Of course, you can also assign the variable to be the amount of money invested in the other account of 8.5% interest rate. It really doesn't matter. Okay, so in this problem, let's just let X be the amount of money invested in the 5% simple interest rate account. And then because the $6,000 in total, then you just subtract the X from this $6,000. That it will give you the money or principal invested in the other account of 8.5% interest account. So the remainder, $6,000 minus X, is in the 8.5 simple interest account, right? So then we have the principles in the two accounts. We can calculate the interest from each program, each account. So the interest from the 5% simple interest account is just the principal, which we assume as X times the interest rate 5%. So 5% is 0.05. So we got the 0.05X for the total interest from the first account in the year. You can similarly do the interest from the other account with 8.5%. So interest from the 8.5 simple interest account, it's just principal, which is 6,000 minus X that he put in the account initially at the beginning of the year times the interest rate 8.5%. And again, convert 8.5% into decimal, you get 0.085. So multiply the principal 6,000 minus X by the rate 0.085. You distribute the 0.085 into the two terms in the parentheses, you get the 5 times 0.085x, 6,000 minus the times 0.085, which is it's just 5 times. So then we get the two interest from the accounts, the two accounts in the whole year. Then you just add them up. You should get 370. So that's the total interest. 370 equals 0.05x. That's the interest from the first account of 5% rate, and then plus 510 minus 0.085x. That's the interest from the 8.5% rate account for the whole year. So then you group like terms or combine like terms. So you subtract 510 on both sides, and at the same time you can combine the right hand side to 0.05x minus 0.085x. So if you do that, you get a negative 150 from subtracting 370 and 510. And then you get negative 0.035x on the right side if you subtract those two terms with the decimal coefficients. Okay. So at the end, you divide the negative 140 by negative 0.035 on both sides, and you get 4,000 to the answer for x. And remember, x is the amount of money invested in the 5% interest rate account. So that was the money initially he put in the first account of 5% rate. Obviously, if you subtract that 4,000 from the total of 6,000, you get 2,000. That's the principal he put at the beginning of the year in the 8% simple interest account. Any questions for this problem? Okay, no problem. And then let's do another one for the next. Applications. Okay, so for the uniform motion, I think we did this example last time, did we? Yes, I think someone asked me about this, what is called. So yeah, let's just do the next. All right, I think we did some examples. We just repeated it. Okay. Okay, this problem is another case. It's called a mixture problem. It says if you have two solutions with the same kind of material but different solutions, you mix them, you're going to get another concentration for the resulting solution. So a chemist mixes a 11% hydrochloric acid solution with a 6% hydrochloric acid solution. So he has two HCl hydrochloric acid solutions, one with 11% concentration and the other with 6% concentration. Okay, so then he mixed them, and then he got 6 milliliters for the volume, and the resulting concentration is 8%. Okay, so the question is, how many milliliters of each solution should the chemist use to make a 600 milliliter solution? That is 8% hydrochloric acid. Okay, so he has two solutions of hydrochloric acid with two different concentrations. One is 11% and the other is 6%. And then he mixed them. He got 6 milliliters. That's the total volume of these two solutions. And the concentration he got from the mixture is 8%. Okay. So we want to know how much or how many milliliters of each solution that he used in order to get that 600 milliliters, 8% hydrochloric acid. Okay, again, you start to assign the variable to be the question asked. So again, we have two solutions, and you can select any one to start. For example, we can select 11%. So let X be the volume of 11% hydrochloric acid solution needed. You can also let X be the volume of the other solution, 6% solution, but it really doesn't matter. You get the same answer. Okay. So then 600 minus X is the volume of 6% hydrochloric acid solution needed, because the resulting solution has 600 milliliters in the volume. So that means the previous two solutions have a total volume of 600. The volume doesn't change, we assume, before and after mixture. So if X is the volume before he mixed it for the 1100 acid solution, then 600X, the remainder, has to be the volume of the other solution, which is 600%. 6%, okay? And then we use the formula for the pure hydrochloric acid in a solution. Okay, so in a solution you have both the pure hydrochloric acid and water. Remember, just like when you make a salt solution, the concentration is just the pure salt you put in divided by the volume of water. So here we got the similar situation. So you can compute the pure hydrochloric acid in the solution by taking the product of the volume of the solution times the concentration. Okay, so volume times concentration. That gives you the pure hydrochloric acid in a solution. All right. So then we had two solutions to start. So each of the solutions has some pure hydrochloric acid in it. So we can compute each of them. So the pure hydrochloric acid in the 11% hydrochloric acid solution before mixing, it's just the volume X. Remember, X is the volume for this solution before mixing, times the concentration. Okay, so that's 0.11. So we get 0.11X. And we can do a similar thing for the pure hydrochloric acid in 6% the hydrochloric acid solution before mixing. Okay, so that's the other solution before mixing. We want to get the pure hydrochloric acid in here too. So it's 600 minus X. That's the volume of that solution before mixing times its solution 6%. Okay, so again, you just and convert 6% 0.06 and distribute to 600 and X. You got 36 minus 0.06X. Okay. And then these two solutions are mixed up. So the pure hydrochloric acid also add up when you mix them, right? But then afterwards, after you mix those two solutions, you get the pure hydrochloric acid in 8% hydrochloric acid solution after mixing. The same, okay? They should be the same. So if you calculate the pure hydrochloric acid in the resulting solution, which is 8%, you just multiply 600 by 8%. 600, remember, is the volume after mixing times the concentration after mixing 8%, or 0.08, you get 48. So this is pure hydrochloric acid after mixing, and we got two pure chloric acid before mixing. So you mix the two solutions, and so you add the pure hydrochloric acid in the two components. So you got 0.11x plus 36 minus 0.06x. We got the previous steps. That gives you the pure hydrochloric acid in the two solutions. So you mix them. That means you add them up, and that should give you the same amount as in the pure hydrochloric acid after mixing, which is 48. We have computed. So then you can solve this equation again by combining like terms. So you can combine 0.11x minus 0.06x on the left, and then subtract 36 on the right to get 12, and then you get 0.05x on the left, and then divide by 0.05 on that, so you get 12 over 0.05, which is 240 milliliters. So this is the volume of 11% hydrochloric acid solution needed before mixing. Remember, X is the volume of this 11% acid before mixing. All right, and then the remainder, which is 600 minus 240. Remember, 600 is the total volume after mixing. So if you subtract 240, you get the other solution volume, which is 360 milliliters. So that's the 6% hydrochloric acid solution needed. Yes, what's your question, Elijah? Type in here. I cannot hear you. Please. Why would you not distribute the 0.1 to the 600? No, because okay, because we're talking about the wait. Okay, because we're talking about the pure hydrochloric acid in each solution before mixing. X is the volume of the 11% solution, and 600 minus X is the volume for the 6% solution. So you multiply 600 by 600 minus X by 6%. Then you distribute. In the other case, you just multiply X by 11% because X is the volume for 11% concentration solution, and the 600 minus X is the volume for the other solution of percent. Okay, does it make sense? You multiply the concentration of each solution before mixing by its volume. X is the volume of the 11% acid before mixing. So you multiply X by 11%. And the 600 minus X is the volume of the 6% solution before mixing. So you multiply this volume by its concentration 6%. Then you need to distribute. Does it make sense? All right. So that's why. Good. So let's just do the last problem. Okay. This one is not so complicated, but it's easy to make a mistake. Okay. So this is called the work problem. So basically, it says you have different people working on the same project at the same time. So you want to know how long it takes. If you know each person needs, how much time to complete it individually, Then if they work together, how long it will take? Okay, so in this example, it says it takes 3 days for Ken to complete a task independently. So he just does it himself, and it takes 3 days for him to finish it. Well, at the same time, for another person, John, he needs 4 days to complete it for the same job, but they do the job independently. Okay, so now if they work together, how long will they need? Okay, I think I put the extra day here. If they work together, okay. So 3 days and 4 days are the time for each people to complete the task independently without any help from others. Now they are working together, so it should not take 3 or 4 days, right? So again, assign the variable to the question asked in the problem. We have 2 people, so you can, just assign X be the days needed for them to working together to finish the job. Well, that's the question. How long will they need? So let X be the days needed for them working together to finish the job. Okay, then we can find the percentage of the job done by each person. For example, the percentage of the job done by Ken is just X over 3. Okay, because X days they complete the whole job together. Can you start doing the problem instead of like explaining? Okay, yes. Okay, I want to make sure everybody understand what's going on. Okay, so the percentage of the job done by Ken is X over 3. X is the days they work together to complete it, but if you divide by 3, that's the part he finishes, the percentage he does in this job. And the percentage of the job done by Ken is X over 4 because he needs 4 days to complete the whole job, but he actually just works X days when they work together. So that's the percentage done by Ken in the X days for the job. Okay, so so if you add the 2% percentage, you should get 100% because they complete the job together in X days. Okay, so that it equals 100%. It's just 1. Okay, then you solve the equation x over 3 x over 4 equal to 1. And we know how to add fractions. We need to convert each fraction by using the least common denominator, which is 3 times 4, so that's 12. So you rewrite the first fraction as 4x over 12. If you multiply 4 on the top and at the bottom at the same time, you got the 4x over 12. And similarly, you multiply 3 in the second term on the top and at the bottom at the same time, you got 3x over 12, right? And then you can add the numerators, 4x and 3x, you get 7x. And you keep the denominator 12. So you get 7x over 12 equal to 1. And then you just flip 7 over 12 to get x. So that is just the 12 over 7. So that's the days they need to complete the job if they work together. And you can see that makes sense. It's a little less than 2 days, because they need 3 and 4 days. So if they work together, it should take a shorter time, isn't it? So so we just finished this section. Any questions for the problem? If you don't have any question about the problem, then I'm going to answer other questions. Any questions for this for today's class? You can type your question here because we don't have the voice thing working. Is good, Samantha? Okay, looks like nobody has questions for the problems. So let me just stop the recording here and then I will